Hi, Miss Putman here. Today we will be reviewing the skill NF.3. We're just going to be working with a part of this. Students were introduced to this skill in 3rd grade, but it's been a while since they've had to do this, so we are going to review how to convert mixed numbers to improper fractions and then back to mixed numbers. So the lesson objective today is we're going to be able to draw fraction bars to show understanding of mixed numbers and improper fractions. We'll also be able to identify and write the fractions in both forms, in both mixed and improper. So the first question is, what is a mixed number? A mixed number has a part that is a whole and a part that is a fraction. Now we do know that a fraction is not a whole number. So a mixed number, there is a full whole, so all of them, all the pieces are there, and then the second part is the fraction. So we have the whole number and then the fraction. The fraction is not a whole, so something is missing. And we either have to figure out what's missing or what is there. It just depends on what the question's asking. So looking at this, we can see that the first square is completely full, completely green, and it's just one big piece. Now we can look at it and see that it can be equally cut into fourths, just like the square next to it. But for this sake, we're just going to keep it as one large piece, which is a whole. Now the second piece beside of it, 3 out of 4 are shaded, so we call that 3/4. So while looking at this, I can say, what is my mixed number? Well, I have one whole and then 3/4 are shaded, so it's 1 and 3/4. That's how we are able to identify mixed numbers. Next, what is an improper fraction? Improper fraction, as we know, an improper fraction is when the number on top is bigger than the number on the bottom. I like to think of it as like a hot air balloon. A hot air balloon, you have the basket in the bottom and it's small, and the balloon is huge on top. So that's kind of how I remember an improper fraction. It's always bigger on the top than the bottom. So a fraction is when the numerator is greater than the denominator. So identifying improper fractions aren't going to be too terrible, because if the top number is larger, and I'm going to say larger, I'm not saying the same, larger than the denominator, then that's how you know it's an improper fraction. Now, if the numerator is the same number as the denominator, it is equal to one whole, no matter what number it is. 4/4, one whole. 10/10, one whole. 12/12, one whole. 1,000,000/1,000,000, one whole. All right, so we're going to figure out how we can take an improper fraction and go to a mixed number, and then a mixed number into an improper fraction. So we're first going to start with converting a mixed number. Oh, I got the wrong word. Converting a mixed number to an improper fraction. I actually have my slides backwards. So let's look at this picture, this right here. Sorry about my words, they're mixed up, but how to convert a mixed number into an improper fraction. So if you look, you will see that we have four holes, 1, 2, 3, 4 holes, with the last triangle being a fraction because it's not completely filled in. So I can see I have 1, 2, 3, 4 holes and then 1/2 not. So this is where it gets fun. This is where we call it a C. You start at the denominator and you do 2 times 4, which equals 8, plus 1 equals 9. So you got 9/2. Or you can even count how many are shaded. 1, 2, 3, 4, 5, 6, 7, 8, 9 are shaded. So 9 is the numerator because the shaded part of a fraction is always in the numerator. And the total number in the whole, the total number of pieces in a whole is in the denominator, and the total number of pieces in the whole is 2. So my numerator is 9 and my denominator is 2. So my improper fraction is 9/2. Now, how do I go from an improper fraction back to a mixed number? So, like I said, sorry, my words, I put the wrong picture on the wrong slide. But we have an improper fraction right here. And as you can see, we have 7/3 because 7 is greater than 3, so I know it's improper. But I know that in one whole, I should have 3 parts. So I'm going to draw one rectangle with 3 holes. Right there is my first hole with 3. But I'm not at 7 yet, so let's keep going. My second piece, my second rectangle has to have 3 as well because that's my denominator still. So we have 3 here, 3 in the second one, but I'm still not at 7, so I have to draw a complete third hole. And I know that seems maybe a little tricky, so think of it as pizza. The first rectangle is pizza 1, the second rectangle is pizza 2, and then the third is the third pizza. Let's say you ordered 3 pizzas and you ate 7 out of your 3 pizzas. So how many pizzas did you order? 3, which is your total. And how many were 8? 7. So you ate 7 out of 3. So you can draw it using that method, pulling out the holes with the denominator 3, 3, 3 until you get to 7. Or you can go back. 3 times 2 is 6 plus 1 is 7, and you can do division that way. So how many times can 3 go into 7? It can go 2 times. What's left over? 1/3. All right. So now let's practice and let's get. All right. Let's practice with the fraction, improper fraction. Let's say 5/3. All right, with using 5/3, we know my whole has to have at least, I'm sorry, not at least, it has to have 3 parts because that's what my denominator says. So there are my 3 parts to make my whole. So if I was to shade that in, 1, 2, 3. But I need 5 shaded, so I have got to create a second rectangle. And I have to cut it again into thirds because my denominator tells me how many pieces are in my whole. So we have 3 here, and then we need to shade in 2 more here. So looking at this, I have 3 plus 2. So 1/3, and then 1/3, 1/3, 1/3, and 1/3. And that gives me a total of 5/3. So there is my improper fraction using the fraction bars. Now, let's take that same problem and let's get rid of the decomposing is what we call it, decomposing of the picture, and let's go ahead and create it into a mixed number. So when looking at this, I can see that this is completely shaded, so that is equal to 1 whole. Looking at my second part, I can see only 2 are shaded and this one is left blank. So I know I have 2 out of how many total pieces? 3. So 1 2/3 is the mixed number of 5 3/4. Now, remember I talked about using the C method? Using the C method, I always start here at the bottom and I do a really big C, kind of like C for Courtney. And I do 3 times 1 plus 2. So that is 3 times 1 is 3 plus 2 is 5. And then you bring down your denominator, the same denominator. The denominator does not change. So that is how we take an improper fraction to a mixed number. And then here we go from a mixed number to an improper fraction. All right, let's do another one because practice is important to this. So let's do the improper fraction. Well, actually, let's start with a mixed number this time. Let's do a mixed number of 2, and let's do 2. Oh, let's get rid of that. 2/3. Let's stick with smaller numbers. All right, so here is my mixed number. I can do it 1 of 2 ways. I could draw it out because I know I have 2 holes. Now, how do I know what how many to cut my boxes into? I look at my denominator. So I cut that into thirds, 1/3, 2/3, 3/3, and then again. Oh, that is so not even. Apologize about that. Let's do that one more time. A third there and a third there. Now, I have 2 holes, which there are my 2 holes. I haven't shaded them yet, but there are 2 holes, and I have a fraction. So I know I'm going to need at least a third box because if I shade in those first 2, which I'll show you in just a moment. Okay, 1, 2, 3. 1, 2, 3. There are my 2 holes, completely whole. Okay, so they're shaded all the way in. And now look at my fraction, which is 2/3. I need to shade in 2 of the last 3. Now here is the drawing of how from a mixed number to an improper. So now all I need to do is count the shaded. And I got 1, 2, 3, 4, 5, 6, 7, 8. 8, and my denominator does not change, so 8/3, which we say 8/3. So that is one method. The second method, which however you want to do it, there is no, it's just a preference. We're going to rewrite 2 2/3 right here. And this is where we use the C. I'm going to come over. 3 times 2 plus 2. I always circle that plus. I didn't on the last problem, but I like to circle that plus just so I can keep it separate, because sometimes if you glance at it, it looks like a multiplication. I don't want you doing 3 times 2 times 2, because then it wouldn't work. But 3 times 2 is 6 plus 2 is 8, which is 8/3, which is 8/3. Now, before we go to this method, like I said, it is preference, but please make sure your child does understand this, because I want them to be able to draw it out. I want them to see the pictorial of this, and I want them to really understand how to find the improper using the drawing, and how to find the mix using the drawing. It will just help them see it and apply it to their math, and not just a shortcut, because shortcuts are great. Don't get me wrong, shortcuts are great, but we're really looking for that deep understanding when it comes to fractions, because the more they understand, the better they are. And I just realized you cannot see my mixed number because my head is in the way using the C method. So I'm going to come over here and redo it. So there's 2 2/3 using the C. We do 3 times 2 plus 2. 3 times 2 is 6 plus 2 is 8/3. Okay, if you have any questions, please let us know. Thank you for watching this video, and thank you for being so awesome. So now practice, 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 and let us know if you have any other questions. Thank you. See you next time.